Hello. Today I will be going over how to find the vertical and horizontal asymptotes of an equation. Now, asymptotes, to start, are where a graph never touches a point and may continue on to infinity or negative infinity. Now, in mathematical terms, we would classify the vertical asymptote as where we find the line is equal to x equals c. To find a vertical asymptote, I can give you an equation such as f of x equals or x over x minus 2. Now, usually to find a vertical asymptote, we would look at the denominator and look at the equation, which here it would be x minus 2. And then we'd solve it for 0. So in this case, at 0, x equals 2. And when x is equal to 2, you have a vertical asymptote in this function. Simple. Now, to find a horizontal asymptote, there are a couple rules. When looking at an equation such as, let's say, x squared over x squared plus 2, you look at the degrees of the function f of x equals, okay. Now, because these degrees are the same, what you would do is find the two constants of both of these, which would be both 1, and that would be your horizontal asymptote, which would be at 1, when y, or f of x or y is equal to 1. Now, for a better example, I can give you 3 of x squared plus 6 x squared plus 4. Here, the degrees are the same, so we just divide out the two constants. 3 divided by 6 equals 1/2, and that would be your horizontal asymptote for that equation. Now, another rule that applies is if the numerator's degree is higher than the denominator's degree. In this case, let's say 4x to the 6th power plus 4x and over 4x to the 4th power minus 2x squared. Here, the leading degrees would be 6 on the top and 4 in the denominator. Because the numerator has a higher degree, we would go ahead and assume that the horizontal asymptote would be when y is equal to infinity. That would be the horizontal asymptote. Or, matter of fact, the asymptote would be infinity. Now, the other way around, if 4x to the 4th minus 2x squared was in the numerator, and 4x to the 6th plus 4x is in the denominator, then the numerator would have a smaller degree than the denominator. Therefore, the horizontal asymptote would be 0. So, in review, asymptotes are where a graph never touches a point in a graph and may continue to infinity or negative infinity. And I will be giving you a picture just in case. Here's a graph, and at this point right here, what we'll say is, let's say this is G. At G, the graph will never touch and will continue on to infinity, but will never touch G. That is an example of an asymptote. So back in review, a vertical asymptote can be found when you have a fraction, and in the denominator you solve for zero, and that would be your vertical asymptote. If there is not a fraction, there is no vertical asymptote, and if it is a polynomial, then there is no asymptote. Here in the horizontal asymptote, when the degree is the same, you can always divide out the constants of the leading degrees in the numerator and denominator, and that would be your horizontal asymptote. If the degree is higher than the numerator over the denominator, then the horizontal asymptote would be infinity, and if the denominator is leading in degrees over the numerator, then the horizontal asymptote would be 0. And that is asymptotes and how to find them.